right, so I'm Amy Sullivan. I'm a structural engineer at KPFF, and I'm here to talk about Federal Center South, which, if you're not familiar, it's a project that's just south of downtown Seattle on the banks of the Duwamish River. And at this point, I would consider it an oldie but goodie. It finished construction almost 10 years ago now. Move-in was in October of 2012. But it's still one of my favorite projects to talk about because of the extensive use of reclaimed timber. So just kind of at a high level, this project is just over 200,000 square feet. $72 million is the total project cost, 3 years from when the RFQ hit the streets to move in. So it moved at a really fast pace. And my favorite stat is 200,000 board feet of timber reclaimed and reused on this project. So I'm just going to start by saying I don't nearly have enough time to talk about all the fun details of this project. So my strategy will be to talk fast. For sure, welcome questions at the end or after the meeting if you want to reach out to me. And then the other thing is I just want to make sure that kind of in all the details that the real main points are highlighted that I'll touch on. So I'm going to make those super obvious as we go through the presentation. But really, I want to talk about the commitment from the team, which was key. I'm going to share the sacred strategy to maximize the reuse of timber and limit the waste. I'm going to talk about the inventory-based design process and kind of the iterative nature of that, which is important to be aware of. And finally, strategies for designing and detailing for efficient fabrication and construction, which is just especially important for this kind of material. So to start out with the team, the owner is the GSA, the tenant is the Army Corps of Engineers, our contractor was Sullivan, CGF was the architect, KPFF did civil and structural, and Flack & Kurtz did the mechanical design. And there's a whole nother great sustainable story around the mechanical on this project, which I won't touch on at all. So the 3 points that I want to make here is, number one, this project was advertised as an adaptive reuse. So the language in the RFP said that this project was to reuse the existing 1940s warehouse that occupied the site at the time. So that language in the RFP from the owner really set this project in motion in the direction that it ended up in. The second point is our team's response to the RFP included a design that committed to reusing that timber, not just as finishes or furniture or site elements, but we committed to a design that repurposed this timber as the structural system in the new building, which was ambitious and exciting and a really big deal. The last thing that I want to point out here is the day the project was awarded, Sullivan brought on the timber subcontractor GR Plume. And so the point here is that this project would not have been possible without the right players in place at the very start, and having the timber sub on board at the very start was super important. So big point here, the commitment from the team and having the right people from the start was super key. Okay, so next I'm going to talk about the inventory-based design process, starting with the sourcing of the timber. So the thing that was really unique about this project is it wasn't that we were deciding that we were going to use reclaimed timber and then try to figure out where it was coming from. We already knew what the source was. So from the very start, we could see what we were working with. So we reviewed the existing plans, figured out what members were in this building. We toured the site to check out the condition. And then at the end of this process, we had a tally of all of the members that we had available to us, which is kind of a unique starting place. And I think an important step in the process is try to make sure that you can source the material that you're wanting to use. So here is the sacred strategy. So when you're reusing reclaimed timber, especially these big pieces, it's really important to not mill them down to smaller sizes because there's so much waste in that process. These big timbers have deep checks in them. So as soon as you start cutting it up, you end up with these little pieces that are just wasteful. So you really need to embrace that timber kind of in the form that it's in. So right in SD, we took this list of members and we started to figure out how these pieces of wood were going to work their way into our design. The system that we came up with is a 3-story structure that has a 4-inch concrete topping that's supported by 2x6 timber decking, which was also reclaimed from the existing warehouse. We've got timbered purlins, those are 8x16. We have some steel beams to help us make some nice long spans and create nice open spaces. And then it's all supported by reclaimed timber columns. So really early on, even apart from just the construction schedule, we needed to start the deconstruction so we can really understand the material that we were working with. At this point, we had a list of member sizes, but we really didn't know anything else about the material. One thing to note is, of course, when you deconstruct a building, it's way different than demolishing it. But even so, there's some damage of the members coming out. And so one thing we took into account from the start is just knowing that we wouldn't get that full length from the members, that we would use something shorter so we could cut off the ends where those existing connections were happening, where there'd be some damage and some bolt holes and that sort of thing. So to have a clean member, we cut some off from the ends, and that helped us set our grid spacing from the beginning. So the next step was grading, sorting, and measuring this material. So every member was graded, so we understood the strength of the material. It all graded really good. This material is like second growth timber, not old growth. All Douglas fir, it graded out as number 1, and flex structural for the most part, which was fantastic. All the members were tagged with their grading and their piece number and their measurements. And at this point, we had another spreadsheet to work with, in this case, a much bigger spreadsheet that had all the details for each piece. And we had the length and the height and the width, but also some really sort of intricate measurements that is kind of unique to this reclaimed timber material, which I'll touch on a little bit more. So we had a lot of detail for each member. So the next point I want to make is just kind of this idea of this iterative process. So we have these two sort of parallel paths happening at the same time. On the one hand, we're just taking stock of this inventory and understanding what it is. On the other hand, we're moving forward with a design based on assumptions about what we think that material is. So you can imagine that we need to check in along the way to make sure that our assumptions are consistent with what we're finding out about this material. And of course, there's going to be some cases where we're going to find something that didn't work as planned, and we're going to encounter some hurdles. And so one of the big hurdles that we came across was when we started doing our calculations to figure out how we needed to space these members out in order to carry the loads. Our calculations showed that we needed to space them out at 4 feet on center. However, we only had enough material. We didn't have enough material to space them out at 4 feet on center. We needed to space them out at least at 5 feet to get them to cover the square footage. So the team came together and talked about what are the options to kind of overcome this hurdle. And what we decided to do was to make the timber composite with the concrete topping, which was already in place in the project. We talked about a lot of different ways that we could do that. And what we decided on involved just adding a lag screw from the timber beam to the concrete to make those two materials act together. So the point I want to make here is this iterative design process kind of creates these hurdles or these unexpected situations, and we really need the whole team's input, and we kind of have to unfold that whole process to find the best solution. So in this case, the solution really prioritized what made sense from a construction standpoint and a fabrication standpoint, and that was deemed to be the best solution. From a design standpoint, this solution hadn't been vetted or tested in the United States. It's not codified. So in order for us to do what we needed to do on the design side, we had to create a test program. So that's what we did. We built some specimens and we tested this idea to make sure that it would work for us. Sullivan built the test program right there on site. We loaded up the beams a lot. It passed with flying colors, and we were able to move forward with this solution. So that was just a great example of commitment to the solution and then finding a clever way to solve it. So the last thing I want to touch on is the detailing and the fabrication. So at this point, we have this really great supply of timber. We've got a design that uses it really efficiently, but now we have to figure out how to implement it in a way that really makes sense from a fabrication and a field fit up standpoint, so that this project doesn't take forever to build, that it can be built in a way that's economical and works with the schedule. The challenge for this project, I would say, is twofold. One, all of the connections are exposed, so it has to look really good. And number two, and this is something that's unique to the reclaimed timber, is these are big pieces of wood that over time, as they dry out, they warp and they shrink and they twist. And so we have these pieces of wood that aren't square and true, and we have to figure out how to incorporate them into a new building in a way that looks good and fits up well. So this is what that looks like. It presents itself in cup and bow and crook and twist. So we've got these really twisty, kind of crazy members. So the big point here is, as we're solving how to do this, we just really need to think about the efficiency of the fabrication. So here are some of those beams fit up. I wanted to show this slide because it really exaggerates the twist of those beams. And because of that, the decision that we made early on with the input from the timber subcontractor is that we weren't going to try to fit up those members with any kind of buckets or side plates. That's a really common connection for wood, is you kind of put a couple steel plates on the side and you bolt it together. But with the twist of those members, that just wasn't going to work and it wasn't going to look good. So we came through and we created these kerf connections that could go vertical, and then the twisting members could just twist kind of independent of what that connection was. So the other trick was how to put a flat level floor on top of these twisty members. So you could mill it down to something smaller, but in order to get all these members square and true and kind of equal size, you would just have so much loss that it wasn't going to work for us. So the solution was to just create these little notches at the top that were just big enough to get the job done. And so I personally had to go into that great big spreadsheet and figure out what that notch needed to look like, how big it needed to be, so we could set a top of steel elevation and a deck bearing elevation. And that was like a weeks long process to try to figure out how that was all going to work. We set it so we didn't have to notch anything. It just got shimmed up at the bottom. And this is what that looked like on these kind of warped, twisted members. And it fit up super easy, dropped into place, the decking, the lag screws, and the concrete. And then we had our nice flat level floor. All right. So this is a picture of what it looks like when it was all done. Again, I just want to point out that the magic of this design process and this building was really just the commitment and just the input from the whole team. It was super collaborative, and it was just really fun to be a part of. So that's what I have.